Assalamu alaikum dear students. In previous lecture we discussed definite integral as the limit of sum. Today we are going to discuss this exercise 7.8, that is we solve we will solve these definite integrals by using the concept of limit of a sum. Now the first one is find the integral from 2 to 3 of x square dx, that is integrate x square from 2 to 3. Clearly it is of the form of integral ab fx dx, where a is 2, b is 3, f of x is x square. We know that h in the definition of definite integral as a limit of sum is equals to b minus a upon n, which is 3 minus 2 upon n, that is 1 by n. Now this 1, as n tends to infinity, this h will tend to 0. We know that by definition a to b fx dx integral equals to limit n tends to infinity b minus a by n, or h into f of a plus h, f of a plus 2h, f of a plus 3h, so on to f of a plus nh. Now which implies that 2 to 3 integral x square dx becomes limit n tends to infinity b minus a is 1, f of 2 plus h, so on to f of 2 plus nh upon n. Now f of x is x square, which implies that f of h, f of 2 plus h equals to 2 plus h square. Similarly, f of 2 plus 2h is 2 plus 2h whole square, so on to f of 2 plus 2, f of 2 plus 2nh becomes f of, sorry, 2 plus nh whole square. Now break this square, which implies that for this 2 plus h it is 2 square, h square, and 2h. Now similarly for this 2 plus 2h square, it is 2 square plus 2h square plus 2 into 2 2h plus so on to 2 square plus nh square plus 2 into 2 nh. Now here we have 2 square but n times, so we can simply write 2 square plus 2 square up to n times, because here we have n number of 2 squares. Similarly in this we will consider this the linear powers of h. Now first term is 2 into 2h, second term is now second term is 2 plus 2h ka square, which implies that here linear term is 2 into 2h. Now for this last term we have 2 into 2nh. Similarly here we have h square, 2h square up to nh square, like this. Now here we have n 2 square is n times, so it is simply n into 2 square. Now here the minimum number in this is 4, so taking 4 out, it is h plus 2h plus 3h plus nh. Again by taking h out, we simply get 4h into 1 plus 2 plus 3 up to n. Now here we have h square, taking h square common, we get 1 square plus 2 square up to n square. You know that sum of first n numbers 1 plus 2 plus up to n is n into n plus 1 by 2, so that is 4n is here, 2 2s are 4, it is 4n plus 4h into n plus 1 by 2, it is h square. Now the sum of the first n squares is n into n plus 1, 2n plus 1 upon 6. But h is equal to 1 by n, so putting h is equal to 1 by n in this equation, it is 1 4n, h is here 1 by n, so this n will cancel with this h square is 1 by n, h square is 1 by h is 1 by n, which implies that h square is 1 by n square. Now distribute this denominator, so here we get 4. Now when 2 and 2 cancel, 2 and 2 cancels in this 4, so it is 2 plus 1 by n. Because this n will cancel with this n, we will get h into n plus 1, which is simply 1 plus 1 by n. Similarly here, this n will cancel with this n. We are left with h square into n plus 1 into 2n plus 1. But h square is 1 by n square, which implies that here we will get 1 by n square. So it can be written as 1 by 6. 1 plus 1 by n into 2 plus 1 by n. By taking n common, we get n square in the denominator. So letting n tends to infinity, it is 4 plus 2. Now 1 by n is 0, plus 1 upon 6 into 1 plus 0 into 2 plus 0, that is simply 1 by 6 into 2. Now this is 4 plus 2 is 5. 2 by 6 is 1 by 3, which implies that 19 by 3. So 19 by 3 is the value of this definite integral by using the concept of limit of a sum. Similarly, if we consider an example, integrate ex from -1 to 1. Here a is -1, b is 1, f of x is e raised to power x. H is b minus a upon n, which implies that 1 minus 1 upon n is 2 by n, which this number tends to 0 as n tends to infinity. So by definition, a to b f dx, limit n tends to infinity, b minus a upon n. Now you can also take f of a plus h up to f of a plus n minus 1 into h. Now if you put, or if you start from a plus h, then you have to put at last f of a plus nh. Here I start from a, that is why I stop at a plus n minus 1 into h. Now substituting these values, we simply get f of minus 1, here 2 by n, f of minus 1 plus h, so on to f of minus 1 plus n minus 1 into h. Now putting this value in this f of x, we get f of x is ex, which implies that f of minus 1 is e raised to power minus 1 plus e raised to power minus 1 plus h, so on to e raised to power minus 1 plus n minus 1 h. Now here this minus 1, e raised to power minus 1 plus h can be written as e raised to power minus 1 into e raised to power h. Similarly, at last, we can write this as e raised to power minus 1 into e raised to power n minus 1 into h. Now taking e minus 1 common, so we get 2 e raised to power minus 1 by n into 1 plus eh plus e2h, so on to en minus 1h. Here we have n number of terms, and this is the sum of the n terms of sequence of the form of 1 plus ex plus ex, e2x plus e3x, which is this geometric progression. So here first term is a, r is common ratio, which is eh, so Sn is a into Rn minus 1 upon R minus 1, which is simply e raised to power nh minus 1 upon e raised to power h minus 1. So when we put this, so this sum becomes ENH minus 1 upon EH minus 1. But H is 2 by N. So substitute here NH is equal to 2 by N, N will cancel. So we get E square minus 1. E square minus 1 into E raised to power minus 1 into 2 is constant. So it comes out from this limit. That is this. And here we get limit n tends to infinity, e raised 1 upon e raised to power 2n minus 1. Now here we have 2 by n. 2 by n. When we shift to this denominator, it becomes 2 by n in denominator. We know that the standard limit, which is limit h tends to infinity, eh minus 1 upon h is always 1. Here if we put n, here n tends to infinity, 2 by n tends to 0, which implies that limit 2 by n tends to 0, 2 by n tends to 0, 1 upon e raised to power 2 by n minus 1 upon e raised to power 2 by n minus 1 is always 1. Hence the given integral becomes e raised to power 2 minus 1 into e raised to power minus 1, which is e raised to power 1 minus e raised to power minus 1. So e raised to power 1 and e raised to power minus 1 is the value of this this definite integral. Similarly, if you have the definite integral and you are asked to solve this by using the concept of sum of the limit, like if you have the given integral as integral a to b fx plus gx, you can distribute this, or by using this concept of algebra, it is ab fx plus integral a to b gx dx. So solve this using this definition for firstly for this fx and for gx, then you can solve this fx plus gx. So inshallah tomorrow we will discuss this definite integral through antiderivative. So thank you.